let's begin. So, this is literally the last lesson of the unit. So next time will be the test review. So we're going to kind of really quick, just watch. Let's review some things we've learned. So we've been in this unit spending a lot of times graphing different types of functions, and they've been shifted functions from a parent function. Now we did learn that not all functions are necessarily a shift from a parent function. They're still a function, just not a shift from the parent function. So everybody looking at my first example here, is this considered a shift from a parent function? Is it? No, why not? There's two x's. That is not in that pretty format. Like, we cannot determine the shift here. So we would just say we can't determine the shift. It's not from a parent function. It is still probably a function. Now let's look here. This is a shift from the parent function. What's the parent function? Square root of x. Now in words, I want you, as I underline, to describe the shift. Go. Good. Right 2. Up 3. Stretch of 3, reflection over the x-axis. Very good. Okay, moving on. Now we also learned, given a picture of a graph, I need to be able to write the equation. So the first thing you do is say, what kind of function am I even dealing with here? Yep, it's a quadratic on its side. That's a square root function, right, everybody? So we have the square root of x. Now, we look for our special points, right? The special point, where was it shifted? Isn't this my special point? So it went right, left 6, and it went down 3. So let's write that in. So it'd be x plus 6 minus 3. Now remember, the parent function, now look, let's say you didn't know what the parent function looked like. Plug in points, 0, 0, plug in 1, don't I get 1? And so on. Okay. So now look, remember, if it was still not a stretch, it would be over 1 up 1, but it's over 1 down 2. So it was a stretch of 2, and then it was reflected, wasn't it? So negative. And we just wrote the equation. I'm going to make it nice and pretty. Y equals. Everybody good? Now, based on a graph, it makes it really easy. We're going to have to be able to do this today. If we have a graph, we can determine domain and range really easily. What's my domain? -6 to infinity, and my range? Good, -3 to negative infinity, and we write the smaller one first, so negative infinity up to -3. Any questions? Okay, let's move on to this next graph. Can anyone recognize what type of graph it is? Yeah. Yeah, it's a negative x cubed, so the parent function is x cubed, right? Everybody, remember, roots are on their side, right? Roots are on their side. So the parent function here would be x cubed. Now he is pointing out that it's a negative, so that will be a shift, and we'll talk about that. So let's look at the special point. Wouldn't it be that point between those 2 points? Okay, so it was shifted left 4 up 2, so we're going to have this x plus 4 cubed plus 2, and then, yep, it's still over 1 down 1, isn't it? But now you can say to yourself, the original is upward facing. Now, how do I know? Let's pretend you didn't know. Plug in some values into the parent function. 0, 0, 1 over 1. If you plug in -1, you get -1. So isn't it originally looking like that? Well, now it's facing the other way, so it must be negative. All good? Where's my function growing from left to right? Yep, negative infinity to infinity. What's my range? Yep, negative infinity to infinity. It's going down forever, up forever. Awesome. Let's move on to the next thing. This is the last lesson we learned. So, given a piecewise function, piece of different functions, write the equation, working backwards. So in this one, we have 4 different functions. Number 1, what kind of function is it? A quadratic that's been shifted left 6, huh? Yeah? So we would go up here and say, okay, so we have x plus 6 squared, don't we? No shift left and right, no shift up and down, no stretch, no compression, and it's good to go. Now that is for x values between -7 and -4. So I'm going to go like this, -7, -4, right? Now it's great. X is greater than -7. Is it equal to? No, and it's less than or equal to since it's filled in there. Let's go on to function number 2. Isn't this a line? Lines have the form mx plus b. Where's the crossing the plus b at? Plus 2. The y-intercept's 2. What's my slope? So we have 0x plus 2. Wouldn't it be prettier to just write that as 2? 0x is just 0, so we have a 2. And that's for x values between -4 and 1. So you go x between -4 and 1, this and this. Now let's see if we need to fill in some lines. Open here, closed here, right? Okay, moving on to function number 3 here. You say it's a line. Lines have mx plus b's. Now, we've got to continue in the same fashion to see where it does cross b. Right there, right? Down 1 over 1. So I went up 1 over 1. So our y-intercept would be plus 5. And then aren't we going down 1 over 1? Down 1 over 1. So our slope is negative x. Negative 1x, essentially. So now we'd say, okay, negative x plus 5 between 1 and 4. So I'd go x between 1 and 4. Put those in. Fill in where you need to. 1 is not included. 4 is. And then we have a function number 4, which is a square root function, isn't it? That's been shifted right 4 down 2. So we go like this, square root of x minus 4 minus 2. And then isn't it flipped upside down? So negative. And that's for x values from 4 to infinity, isn't it? So that would be x values larger than 4? So you'd say for x values greater than 4. Yes. Yeah, we have to imagine in our head if it wasn't erased, where would it cross? The blue ones? Because that's not how quadratics work, right? We do shifted quadratics. Yeah. Okay, awesome question. Okay, great. So let's get to today's lesson. So we're starting right away. This is 7-4. We're going to be learning about inverse of functions. So we're going to first talk about notation. Now, notation just means how we write things, like how we state something, how we write it. So if we have a function f of x and we go through the process, we'll learn in a minute to find the inverse, we then just have to write it in the proper format. So this like -1 isn't actually a -1. It's literally just saying f inverse of x. Like that -1 just means we have an inverse. So that does not change your anything. It's just how you write an inverse. So same with y. If I find the inverse of y, we would then write y inverse of x or whatever, y inverse. Okay, so that's just notation. So here's our first rule. The first rule is a function's inverse will be a reflection over the y equals x axis. Now I have drawn y equals x right here. Now think about it. Y equals x works like this because you'll have to be able to draw that. Don't overthink it. That's this, 1x plus 0, isn't it? So we start at 0, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I drew it in. So inverse function will be take the original function and reflect it over the y equals x axis. Does that make sense? Like we stack it across that. Yes. Yeah, yes, it would be. Yep, and so now this is rule number 2. So to find the inverse of a relation literally just means a bunch of points. It's not necessarily a quadratic, it's not necessarily a line, it's just a bunch of random points. To find the inverse of a set of points, or even one point, all you have to do is one rule. You take your xy point and you switch it. There's your new xy point. That will give you the inverse. So you should maybe write that down. All right, so let's go ahead and do number 1 on the pink side of the worksheet. We just learned if we have a set of xy points, we can find the inverse by switching x and y. Good. So write it in. Write xy. I'm going to write y inverse so that we can specify this is the inverse, this is the original. So now like literally just switch them. So -3, -4, 1, -3, 2, 1, 4, 3. That is the inverse right there. It's that easy. Now I told you those points will map across this line. So I want to show you. Let's graph the original. So let's graph these xy points. Here we go. You guys know how to graph points. So go down. So -4, -3, plot your point. -3, 1, plot your points. I'm graphing the original function. Over 1 up 2. Over 3 up 4. Just plot those points. Should look like that. We just found our inverse points. So I'm going to graph these now. So we're going to go -3, -4 now. We're going to go over 1 down 3. We're going to go over 2 up 1, it looks like. Then over 4 up 3. Now look, it's looking good. If we literally took this and stamped it over that line, these map perfectly, these map perfectly, these map perfectly, and these map perfectly. So it really works. Questions on that? Pretty easy stuff. Okay, cool. Now I do want to point out something. So I'm going to have you do these ones. I just want to point something out because this was really confusing for last hour. Let's pretend I have these XY points. Let's go like this. -3, -2, -1, 0, 1. And I have this. Okay, and I say find the inverse. We just switch x and y, correct? So I'd have this, -6, -3, -5, -2, -2, -1, -7, 0, and then -8, 1. On a multiple choice test, they're going to take that and they're going to keep it the same XY points, but they're going to reorder it from the lowest to the greatest, your x's. So on a multiple choice test, they would say, oh, well, -8, 1 should be written first, since that's the smallest x. -7, 0. Does that make sense? The XY points don't change. They just reorder x in from least to greatest. So then -6, -3, -5, -2, and then -2, -1. And isn't that from least to greatest for x? Okay, cool. Just making sure so you don't freak out. The same points. Okay, ready to do 1 through 4 on the y. On the y, it tells you to graph it. I do not want you to graph it. Just write your new points just like I did right here. But on the pink number 2, you will graph it. Ready, set, go. At these two functions. So notice by the notation we know the red function is the original function. So here is the original function. And then this green one's our inverse function. Now let's see if it's truly good to go. Because we know how functions work. Shouldn't this map evenly here? And this should map evenly here. And then this will map onto itself. Because look, if we go over 1 up 3, then the inverse will be over 3 up 1, right? And so on. So it looks good to go. So look, over 5 up 5 will switch to be 5, 5. Okay, now I want you, we're really good at graphs, looking at a graph and determining domain and range, which really helps us. So look at the original function. What is my domain? 1 to infinity. You're right. What is the range? 3 to infinity. Okay. Now I'm going to switch your eyeballs. Look at the green one. The inverse. What is my domain? 3 to infinity. My domain would be 3 to infinity. And my range would be 1 to infinity. What do you notice about the domain and ranges? Yeah. Oh, it's not. It's just my drawing isn't perfect. Great question. Yeah, so, yeah, you noticed, aren't they just opposite? You literally just switch them. So the original's domain becomes the range of the inverse. The range of the original will become the domain of the inverse. So that's kind of cool. Because the nice thing is, if you know this and this, you don't even have to think about this. You can just switch them, okay? Sweet, that's a new rule. Okay, I just want to verify what we've learned so far. You don't need to write this down. We've already learned this. So we learned that a function's inverse will be a reflection over y equals x. So look at those points. We've also learned to find the inverse of a set of points, you'll switch x and y. And now we've learned the domain of a function will be the range of the inverse, right? So that also is true to say that the domain of the inverse will be the range of the original. Cool. So now one thing to note, just look up here. If I said, given the red function, it's a quadratic, isn't it? Given the red function, graph the inverse. There's a couple ways we could do it. We could write the equation and figure that out, or we could just take our xy points and switch them. So let's just do that right now. So I have these xy points. I'm going to switch them 6, -1, 3, 0, 2, 1, 3, 2, 6, 3. So watch me graph this. This is interesting. Over 6 down 1, over 3 up 0, over 2 up 1. Yeah, over 3 up 2, over 6 up 3. So I'm going to graph my inverse. All right, so it's like a sideways quadratic, correct? Yeah, yes. Yeah, absolutely. So you will look, you could just kind of look sideways and then look, they map evenly, don't they? A little bit harder to see where they perfectly land, but does that make sense? We just switched X and Y. Now here's what's interesting. If we have a function that's a quadratic and we find the inverse, now the bad news is the inverse is not considered a function. Well, why? Because think about it, it doesn't pass the vertical line test, which means every x value should only have one y value. And look right here, do you see how at 3 we're at 2 y values? It does not pass the vertical line test. So yeah, that is the inverse, but the inverse is not a function. Now that doesn't always happen. It's not that the inverse is never a function. A lot of times it is a function. I'm going to direct your attention back to this example. Wasn't this a function? Doesn't it pass the vertical line test? It doesn't double dip. And doesn't this pass the vertical line test? It doesn't double dip. So this one and its inverse are functions. Yeah. Well, yeah, we could, but look, a quadratic passes the vertical line test, right? It doesn't ever double dip. Oh, no, just separately. Yeah, just separately. Good question. Okay, now I get it. Good point. He makes a good point. A quadratic's inverse is never going to be a function. You're right. Okay, here we go. So now write this down. Now we know all those things. This is the last thing we need to know, and then we're just going to practice. This is the last thing we have to learn, and then we're going to practice. Okay, so we're now going to learn how to find the inverse of an equation. Given an equation of a function, this is how you find an inverse. So first, the first step you do is you take and switch x and y. Now, originally it was in the form y equals a function, so you'll literally just take and switch x and y. Now, second, we want to get it back into y equals form so that it's a function again. So after we switch x and y, we'll just solve for x using solve for y using algebra so that we can get it back in y equals format. So we'll get y alone. Once we've done that, once we've got y alone, we're really done. We just have to write it in the correct format so we can determine the difference between the original function and the inverse. So we'll just put it in the correct format, f inverse, stating, oh, this is our inverse and this is our original, or y inverse, however you want to write it. So those are the steps. So everybody, let's start with number 3 and let's go through these steps. So given this equation of a line, keep in mind linear degree 1. Given the equation of a line, let's find the inverse using algebra. So the first step you do is switch x and y. So write that. X equals 2y minus 3. Now your second step is literally just get y alone again. We need it back into y equals. So when we add 3, you got to go in the correct order. So you have x plus 3 equals 2y. What will we do next? Divide by 2. So we have this. Y is equal to x plus 3 over 2. Now look, this is still linear, degree 1. I need to point something out to you. If I said to you graph this, this would not be the prettiest format to keep it in because lines have a better format written as mx plus b. So let's rewrite this. Let's go up here. I'm going to go, okay, y inverse is officially, I'm going to call this 1/2 x. So I have it in mx plus b form plus 3/2. Does everybody see? Same thing, mathematically. So plus 3/2. I would rather have it in mx plus b form instead of like this form, which is not wrong, but this form is better. So now it did not tell you to graph it. I just want you to watch me graph it, okay? So we know how to graph lines. Don't start wigging out and doing weird things. You'd say, I know that the y-intercept's -3, and then our slope is 2. So watch, up 2 over 1, up 2 over 1, up 2 over 1, and so on. Down 2 over 1. So watch me go ahead and graph this. Now there's a couple different ways I could graph the inverse. I can graph this or I can just switch these xy points, can't I? I'll go ahead and just graph this. So it's a little bit harder. This is 1.5, right? So my y-intercept is up 1.5. And then my slope is up 1 over 2. So from there, you got to be kind of careful with this. Up 1 unit would be there, over 2 units would be there. Up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, 1 over 2, down 1 over 2. I'm going to just draw in, like, just to show you guys something. So look, we know that an inverse will be a reflection over that. Doesn't it look good? Yes. Well, yeah, to make it perfect. Yes, for a line especially, yeah. Okay, cool. Now I'm going to ask you a question. Is a line considered a function? Yeah, so isn't the line became an inverse another line? Aren't they both considered functions? So in this one, a line is a function, so our inverse is a function. I write that. Yes, it is a function. Okay, let's do number 4 together. Here we go. And then I'm going to let you try one by yourself. Let's see. So our first step is to switch x and y. So we have x is equal to y plus 9 over 2. Second step, solve for y. So won't we do what? Yep, multiply both sides by 2. The 2 divides out over here. So we have 2x equals y plus 9. Okay, good. So we have this. Y is equal to 2x minus 9. So I'm going to just come up and write it up here. Y inverse was equal to 2x minus 9. Now I want to point something out up here. It doesn't tell you to graph, so you're not going to, but up here, this was not written in the prettiest format. So just thinking about it, if I was going to graph it, I'd go, okay, I'm going to rewrite this as 1/2 x plus 9 halves, right? Now question for you, is the inverse a function? Yeah, a line is always a function. It passes the vertical line test, yes. Now question for you, even though this is not on there, you're going to be asked to do this later, and I'm just showing you now how to do it. Let's look at the original function. It's a line. Think about a line in general. I'm not drawing that perfectly. I'm just drawing a rough sketch, just a random line. What's the domain of all lines? All real numbers. So now look, don't I directly know that the inverse's range will be all real numbers without even having to think? Yes, now let's talk about the range of a line. Isn't it growing down and up forever? So then my domain must be all real numbers of the inverse, which makes sense. Look, it's a line as well. All good? Cool. Okay, you guys do number 5. Ready, go. Okay, so did you get this done? F inverse of x. What'd you get? 2x plus 4. That is correct. Were you all able to get there? Well, let's quickly go through it then. So we switch x and y. X equals 1/2 y minus 2. What's our first step? Add 2. So we have x plus 2 equals 1/2 y. How do you want to do 1/2 the smart way? Not divide by a half. What should we do? The smart way. Times by 2. So we have to times both sides by 2. Well, if I said sides, don't I need parentheses? Times by 2. So now we distribute 2x plus 4 equals y. Does everybody see now how we got it? Okay, now I'm just curious here. Is the inverse a function? Lines are functions, so you'd say yes. I'm not going to graph it. I just want you to think about in your head the domain and range. Of the original, which was a line, what's my domain? All real numbers. What's my range? All real numbers. So therefore, we know the domain and range of the inverse. Right? Cool. Okay, we're going to do number 6 together. So we're starting with this. The square root of 2x minus 1. Find the inverse. So we switch x and y. So we have x is equal to the square root of 2y minus 1. Now you got to go in the correct order. What should I do? Square both sides. So we have this. X squared equals 2y minus 1. What's my next step? Add 1. So we have x squared plus 1 equals 2y. Then what? Divide by 2, divide by 2. Agreed? Y is now alone. I'm going to go up and write it in the correct format up here. So I'm going to say f inverse of x equals. Now I personally would rather write this quadratic as a shifted quadratic. So I'm going to go like this. 1/2 x squared. Same thing. And then plus 1/2. Everybody see why that might be beneficial? Because then we could say up a half, couldn't we? Okay, cool. So that's our inverse. Now, is a quadratic a function? Yes. A quadratic is a U. Is the quadratic a function? Yes. So it does pass the vertical line test. So our inverse is a function. Good point. So that's why we're going to talk about the domain and range now. Yes. Okay, good point. So he's making a good point, and I'll point that out in a second. Okay, let's look at the domain and range here. This is really important, actually. So everybody, let's look at this. Now, we've learned that you cannot determine the shift if there's something in front of x, right? So this one's a little bit more advanced. We got it. So we can pull out a 2. Now, I don't mean out. I mean out of the term. Then divide by 2, divide by 2. So then left would be x minus 1/2, wouldn't it? So now think about this. Even though the square root of 2 doesn't come out evenly, like we have a decimal. So we have the square root of 2 times the square root of x minus 1/2, don't we? Still a stretch, because the square root of 2 is like 1.7. So don't let it throw you off too much, because we have a calculator. You know, it does all the hard stuff for us. Now, we don't even need a perfect graph. You don't need a calculator. Just think of it like this. What is the shift left and right? What's your shift up and down? What's the shift left and right? Right a half. Any shift up and down? All I need is a rough sketch. So I went right a half, and then there was no shift up and down. Now, yeah, we could draw a perfect graph. I don't need to. I'm just trying to find domain and range. So this stretch will not affect the domain and range, right? It's just how quickly is it going up. Does that make sense? So I'm just going to draw a rough sketch for myself. I don't care if it's perfect. That will help me with domain and range. So what's the domain of this? 1/2 to infinity. Therefore, what's my range of the inverse? 1/2 to infinity. What is my domain of my original? 0 to infinity. Therefore, my domain must be 0 to infinity. Awesome. So that's what you were asking about. So this is the inverse, but it will actually only start at 0 to infinity. So it'll only be the right half of the quadratic. But that's a little bit advanced for a lot of people, so I don't even talk about it. Yeah, does that make sense though now? So it'll only be the right half of the quadratic. Yeah, we won't get into that. Don't worry about that. He's asking an advanced question, which is great, but nobody else, just don't worry about it. Okay, cool. Moving on. Okay, let's do number 7. Here we go. Switch x and y. This is one that is interesting. So x equals 4y squared minus 4. What's my first step? Add 4. So we have x plus 4 equals 4y squared. Then what? No. Divide by 4. Divide by 4. So we have this. X plus 4 over 4 equals y squared. Then what? Square root it. Now remember, when solving and taking a square root, you cannot forget you need a plus or minus. So we have the square root. We need to take a plus and minus in front. So now we have this. Y is equal to plus and minus the square root of x plus 4 over 4. Is everybody with me? So now think about it. That makes sense because don't we have a full quadratic here in the original? Isn't it going to be flipped on its side? So now think about this, guys. This is the top half of a square root function. A negative square root, this is the bottom half of the square root function, the top and the bottom. Does everybody kind of see what I'm talking about? So is this, so let's label it y inverse, is this a function? No, because of the plus and minus. We just said a minute ago, Anthony pointed out all quadratics inverses will not be functions. We can't forget a plus or minus. Okay, let's do domain and range because you're going to have to do that in a minute. Now look back to the original. Let's just graph a rough sketch of this. Isn't the shift down 4? Now remember, this is this is a stretch of 4. That's not going to affect your domain and range. That's just how quick the acceleration is, yes. You could if you're in a way advanced thinker. So if later you can talk to me, yes. Okay, so from here, we're just drawing a rough sketch, not a perfect sketch. I don't care if I'm drawing a perfect sketch. I just want to know domain and range. So what's my domain of the original? Yep, negative infinity to infinity. Therefore, now look, automatically I know my range of the inverse. What is my range of my original? Negative 4 to infinity. Therefore, my domain must be negative 4 to infinity. Awesome. Okay, I want you to do one by yourself. Do number 8 by yourself. So you guys got, and was everybody able to get here? Perfect. Then we would say, is this inverse a function? No, because of the plus or minus, and quadratics flipped on their side would be bad news. Okay, I want you to see if you could do domain and range without my assistance on each of these. Even though it doesn't ask, you're going to be asked later. So, ready? See if you can do the domain and range. Think. I don't even care how perfect the graph is, so that will not affect the domain and range, and we know it's up 5. So what did you say the domain of the original was? All real numbers. Therefore, the range on my inverse is all real numbers. What's the range of my original? 5 to infinity. You're right. Therefore, my domain must be 5 to infinity. You guys are awesome. Let's do another one by yourself. Number 12. So let's have somebody shout out what you got. Plus or minus? So I'm hearing somebody say 5x minus 5 over 2. Yep, good. So you would have first subtracted 1 times by 5. That's where you have to remember to distribute 5 through, people. If you didn't get that, that's where you messed up. Okay, sweet. Your inverse is not a function. Now, once again, in a minute, you're going to have to do the shifts left and right. You're going to have to do domain and range, not even graphing a perfect graph. Don't let this throw you off. Isn't this just this? 2/5 x squared plus 1. That's a compression. That won't affect the domain or range. So we just went up 1. I'm drawing a rough sketch because I don't really care about how quick or slow it's growing up for domain and range. So my domain would be all real numbers. Therefore, my range is all real numbers. The range would be 1 to infinity. Therefore, my domain is 1 to infinity. You guys did so awesome with that. I want you to go to the white and do 5 through 16. 21. Okay, grab one of those graphing papers because it tells you to graph, and there's not a place for you to graph it on there. So there's 2 ways to do this. Everybody watch. It just depends on what you want to do. So, again, I already got one note that's up this one. Okay. Okay, so what we would do is let's graph the original. We know this is a shift of left 2, isn't it? And then from there, you would type it into your calculator, plot points. So I'm going to just tell you the points. Negative 1 up 1 would have been a point. Over negative 3 up 1. Over 0 up 4 would have been a point. Over negative 4 up 4 would have been a point. So we have this quadratic graph now, and we could connect our little dots, but once again, I'm going to make those dots pretty obvious to myself. One way of graphing this would be to simply switch my xy points, wouldn't it be? So we would go over negative 2 up 0. So wouldn't that be go over 0 down 2 now? Over negative 1 up 1. So wouldn't that be over 1 down 1? Switching them. Over negative 3 up 1. So now I'm going to go over 1 down 3. I'm just switching my xy points. And then over negative 4 up 4. Yeah. So then over 4 down 4. Then over 0 up 4. So over 4 up 0. And now I can graph the inverse. That would be one way of doing it. Right? Perfect. Now let's pretend though, this is really how I would do it if it wasn't a quadratic. Let's say that our original was this, for example, 2x minus 3. To me, I would be able to graph this really easily by going down 3 up 2 over 1, right? I wouldn't, right? We know how to graph lines. But I wouldn't want to then switch xy points. Instead, I would just switch x and y. And then I would I'd add 3, right? X plus 3 divided by 2 equals y, which is this, 1/2 x plus 3/2 equals y. I would just rather graph lines like by hand, because that's easier than switching xy points for lines. But for quadratics and stuff, I usually just do this. Does that kind of make sense? Okay, so then last one that I'm going to let you work for pretty much the rest of the time. Let's go to 27. It says, let's read the instructions. For each function, find the inverse and the domain and range of the function and its inverse. So it wants us to find the inverse and then state the domain of the original and range of the original and the inverse. And then it says determine whether the inverse of the function. Yes, I spelled whether wrong. Let's just move on from that. Pretend like I didn't. You didn't even notice. Okay. Yeah, it's apparently that's what last hour told me as well. Well, it's because I spelled that and the book spelled that. Okay, let's be honest. Okay, here we go. So we would switch X and Y. Yeah, I have problems with spelling. It's embarrassing. Well, yeah, that's why I have problems with it. Is because during my whole degree, I never had to write a paper. I just did math. Okay, so the first thing we would do is square both sides. So we have x squared equals y minus 1. And then what, we just add 1? So we just found the inverse. I'm going to make a special little spot for my answer. So we have f inverse of x. We just found to be x squared plus 1. Am I right? Now, because I have to find the domain and range of both the original and the inverse, I'm also going to write the original right here. So my original function, f of x, is equal to the square root of x minus 1. Domain and range, right here. Domain and range. So now, think about it. If I know the domain and range here, I know the domain and range over here. So I'm just going to look right here. And even though it doesn't ask you to graph it, just go like this. Make yourself a little rough sketch. We just want a rough sketch to help us with the domain and range. Isn't this a right one? So go like this, right one, and then just draw a rough sketch. So now it's easy to see your domain. Isn't my domain 1 to infinity? Therefore, then, go down to your range here, 1 to infinity. Now, my range of the original is 0 to infinity. So now we know the domain of the inverse is 0 to infinity, and all is good. Now it says, is the inverse a function? Is a quadratic a function? Yes. And now we've answered it. So what I want you to do is practice some in each section. So we just did one from each section. I want you to practice a couple in each section so I can help you if you need help before we're done. Okay, we still have one more thing to go over, so work. Okay, so this is putting together some different things we've learned this year. So remember, so this is a little different looking. Yeah, so how should we rewrite this? What have we learned on this? This is f inverse composed of f of negative 1. Can anyone remind me how to rewrite it? Good, you're saying squish it backwards? Yeah, so we would take negative 1, squish it back with f of negative 1, squish it back into the inverse. So we have f inverse of f of negative 1, right? So then from there we would say, okay, remember back to this. If we had f of g of 2, for example, what do we calculate g of 2 and then plug that in? So our first thing we're going to do is calculate our function when we plug in negative 1. So go to the function, plug in negative 1. 2 times negative 1 plus 5. Won't that be negative 2 plus 5? Which is 3. So we're literally looking at f inverse of 3. Yep, we put 3 into the inverse. But we have to push pause because we don't know the inverse. We got to hurry and go find it. So we'd say, okay, switch x and y. Now solve for inverse. Subtract 5. X minus 5 equals 2y, divide by 2. So y inverse, or f inverse, same thing, is 1/2 x minus 5/2. Now that we know the f inverse, we can now take 3 and plug it in. So 1/2 times 3 minus 5/2. And then you just take it in your calculator, and we get negative 1/2. Same, you'll get the same thing. Perfect. Awesome. Okay, this is what's required of you to do on the homework. Okay, so you're going to finish all of the white worksheet. And go to the pink. Everybody go to the pink so we can cross them out. Go to the back page of the pink, and we're not going to do 8 through 13. You can literally put an X through those on the pink. And the rest of that you can do.